Hello dear students, welcome back in class 9th chemistry. Students, I hope that you all are fine and studying sincerely. Today in part 5 of chapter 3 Atoms and Molecules, we will learn in detail about molecular mass and formula unit mass. So let's start. Students, in my one video lecture, I have explained the easy tricks to learn the names of first 20 elements with their atomic number, number of protons, number of electrons, number of neutrons, their electronic configuration, their valence electrons and valency. If you want to revise, watch that video once again, whose link is displayed here on the screen. Now, today I will explain the easy trick to learn the atomic mass of first 20 elements. Students, first of all, see the elements highlighted in red color, that is hydrogen, beryllium, nitrogen, chlorine and argon. Remember one thing, except these elements only, our easy trick will be applied to all other elements. Right? Look at this table which shows the name of first 20 elements and their atomic number with their atomic mass. Now it may be very difficult for you to learn the atomic masses of these elements. Students, look at this table. There are two categories of elements. One category where the elements have even atomic number and other category where the elements have odd atomic number. Let's see first the elements having even atomic number. For example, helium with atomic number 2, beryllium with atomic number 4, carbon with atomic number 6, oxygen with atomic number 8, neon with atomic number 10, magnesium with atomic number 12, silicon with atomic number 14, sulfur with atomic number 16, argon with atomic number 18 and calcium with atomic number 20. These elements which have even atomic number are highlighted in green color, so you can easily identify the elements having even atomic number. Now, what is the atomic masses of these elements having even atomic number? You can see here, it's very easy to learn the atomic masses of the elements having even atomic number. You just double their atomic number and you will get their atomic mass. Let's see. Helium with atomic number 2. Just double the number. What is the double number of helium? That is 4. So what is the atomic mass of helium? 4. See one more. Leave this beryllium because it is an exception where this trick will not be applied. See carbon. Carbon with atomic number 6, it is even number. Just double this number, you will get the atomic mass of carbon. So what is the atomic mass of carbon? 12, right? Again, see oxygen with the atomic number 8. 8 is even atomic number. And double this number, you will get the atomic mass of oxygen, that is 16. See now neon with atomic number 10. Again, it is even number. Just double it. You will get atomic mass of neon. This is 20 number. Now see magnesium with atomic number 12. 12 is again an even number. And double this number, you will get the atomic mass of magnesium, 24. Silicon with atomic number 14. It is again an even number. And just double it, you will get the atomic mass of silicon, that is 28. Sulfur, atomic number 16. Again, it is an even number. Just double this number, you will get the atomic mass of sulfur, that is 32. Argon with atomic number 18, it is an even number, but this trick is not applied to this element, so leave this element, it is an exception. Calcium with atomic number 20, again it is an even number, just double this number, you will get the atomic mass of calcium 40. So the elements which are highlighted in this table with green color show the atomic number as even number. You just double the atomic number of these elements having even atomic number, you will get the atomic mass of these elements with their even atomic number. Now see the elements having odd atomic number. And how will you learn the atomic masses of these elements with odd atomic number? It's again very simple. Hydrogen with atomic number 1. This trick will not be applied to hydrogen, so leave it. Lithium with atomic number 3. 3 is an odd number. Now what you have to do, you just double this number and add 1 in it. Like 3, double of 3 is 6 plus 1. It is 7. So you have to double the odd number and add 1 in that number. You will get the atomic mass of that element with odd atomic number. See another example. Boron, atomic number 5. So 5 is again an odd number. You just double this number and do plus 1. So 5 double 10, 10 plus 1, 11. So what is the atomic mass of boron with atomic number 5? It is 11. Nitrogen with odd number, atomic number 7. But this trick is not applied to nitrogen, so leave it. Come to fluorine. 9 atomic number, which is an odd number. Just double the number and add 1 in it. 9 double number 18 plus 1, 19. So atomic mass of fluorine is 19 with atomic number 9. Sodium, atomic number 11, odd number. Double this number and add 1 in it. 11 double number 22 plus 1, 23. Then aluminium, 13, again odd number. Double this number and add 1 in it. 13 double number 26 plus 1, 27. Phosphorus with atomic number 15, again an odd number. Just double this number, that is 30, and add 1 in it, 31. So atomic mass of phosphorus is 31 with atomic number 15. This trick is not applied to chlorine with odd number 17, so leave this. Come to potassium with atomic number 19. Again 19 is an odd number. Double this number. Double of this number is 38 plus 1. It comes out to be 39. So 39 is the atomic mass of potassium with atomic number 19, which is an odd number. So students, it's become very easy for you all to learn the atomic masses of the first 20 elements. Just revise what you have to do, that if the atomic number is in even number, you just double that number, you will get the atomic mass of that element. And if the atomic number of the element is odd in number, and you just double the number and add 1 in it, and you will get the atomic mass of that particular element. So in this way, it becomes very easy for you to learn the atomic masses of first 20 elements with 5 exceptions, that is hydrogen with atomic number 1 and atomic mass 1, beryllium with the atomic number 4 and atomic mass 9, nitrogen with atomic number 7 and atomic mass 14, chlorine with atomic number 17 and atomic mass 35.5. Students, now one question arises in our mind, that why we have to learn atomic masses of these elements. We have to learn the atomic masses of these elements because these atomic masses are needed to calculate the molecular mass of chemical substances. Now let's see what is molecular mass. Students, you know that a molecule is a group of two or more atoms that are held together by attractive forces. As you have learnt the atomic masses of the elements, in the same way, we can calculate the molecular mass of chemical substances. What is molecular mass? And how can we calculate the molecular mass of chemical substances? The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of that substance. It is the relative mass of molecule, so it is expressed in atomic mass unit or unified mass, that is U. Let's see one example. How can you calculate the molecular mass of carbon dioxide? First of all, see the number of carbon atom present in this molecule of carbon dioxide and multiply it with its atomic mass. There is one carbon atom, then multiply it with its atomic mass 12. It comes out to be 1 multiplied by 12 is equal to 12. Then see the number of oxygen atoms present in this molecule. There are 2 atoms of oxygen. So multiply this number with its atomic mass, with the atomic mass of oxygen. It is 16. So multiply 2 atoms of oxygen with its atomic mass. 2 multiplied by 16, it comes out to be 32. Now just add the atomic mass of carbon atom and atomic mass of oxygen atoms, and it comes out to be 44 unified mass. This is the molecular mass of carbon dioxide. See one more example. Calculate the molecular mass of water, H2O. In one molecule of water, there are 2 hydrogen atoms and 1 oxygen atom. So multiply 2 hydrogen atoms with its atomic mass, that is 1. It comes out to be 2 multiplied by 1, that is 2. And multiply 1 atom of oxygen with its atomic mass, that is 16. It comes out to be 1 multiplied by 16. Now just add the atomic mass of hydrogen and atomic mass of oxygen atoms present in this water molecule. It comes out to be 2 plus 16 is equal to 18 unified mass. In this way you will get the molecular mass of H2O, that is 18 unified mass or 18U. Students, take your pen or pencil and notebook to practice some numericals on molecular mass. One such numerical is given as blueprint question on page 40 of chapter 3 in your science textbook. Find out the molecular masses of H2, O2, Cl2, CO2, CH4, C2H6, C2H4, NH3, CH3OH, and tell your answer here. First, molecular mass of H2. How many atoms of hydrogen are present in H2? Yes, you are right. There are 2 hydrogen atoms. So multiply these 2 hydrogen atoms with their atomic mass. So what is the atomic mass of hydrogen? It is 1. So multiply 2 by 1. It comes out to be 2 unified mass. So what is the molecular mass of H2? That is 2U. Now calculate the molecular mass of O2. See how many atoms of oxygen are there in this O2 molecule? Yes, there are 2 atoms. So what you have to do? You multiply this 2 number with the atomic mass of oxygen. What is the atomic mass of oxygen? It is 16. So 2 multiplied by 16, it comes out to be 32U. So what is the molecular mass of O2? It is 32U. Now calculate the molecular mass of chlorine, Cl2. Chlorine molecule. In chlorine molecule, there are 2 atoms of chlorine. Multiply this 2 number with its atomic mass. What is the atomic mass of chlorine? Yes, you have already revised it. The atomic mass of chlorine is 35.5. So multiply 35.5 with 2, as there are 2 atoms of chlorine in Cl2, and it comes out to be 71U. So what is the molecular mass of Cl2? That is 71U. Now calculate the molecular mass of CO2. We have already calculated the molecular mass of CO2 in the previous slide. So do it yourself once again and tally your answer. It comes out to be 44U. Students, similarly you can find the molecular mass of CH4, C2H6, C2H4, NH3, CH3OH, and after calculating their molecular mass, you can tally your answer from this slide. Students, remember one thing, that there are 2 types of compounds. One is molecular compounds, which are formed by the combination of 2 or more nonmetals like CO2, H2O, H2, C6H12O6, NH3. These compounds are held together by covalent bonds, which are formed by the sharing of their valence electrons. These molecular compounds do not contain ions. They do not contain positive and negative ions like cations and anions. They do not form cations and anions. So we use the term molecular mass to calculate the mass of molecules of these compounds. Secondly, there are ionic compounds that are formed by the combination of metals and non-metals. Metals form cations and non-metals form anions. These cations and anions in an ionic compound are held together by ionic bonds. So we use the term formula unit mass to calculate the mass of these ionic compounds. So let's see what is formula unit mass. The formula unit mass of a substance is sum of the atomic masses of all atoms present in a formula unit of a compound. The word formula unit is used for those substances whose constituent elements are ions, means which are made up of ions. The compounds which do not contain ions, we use the term molecular mass. We calculate the molecular mass in those cases. And if the compounds contain ions and we have to calculate the mass of these compounds, we use the term formula unit mass. Otherwise, formula unit mass is calculated in the same manner as we calculate the molecular mass. That is just by adding the atomic masses of all atoms present in a formula unit of compound. Let's see one example to calculate the formula unit mass of NaCl, that is sodium chloride. What we have to see to calculate the formula unit mass of NaCl? We just see the number of sodium atoms and chlorine atoms present in this compound. You can see that in NaCl there is one sodium atom and one chlorine atom. So what we have to do? Just multiply one sodium atom with its atomic mass, that is 23, and one chlorine atom with its atomic mass, that is 35.5, and add the atomic masses of these two atoms. Atomic mass of sodium atom comes out to be 23 and atomic mass of chlorine atom comes out to be 35.5. On adding the atomic masses of sodium and chlorine, we get the atomic mass of NaCl, that is 58.5 U. That is 58.5 unified mass. Now students, let's practice to calculate formula unit mass with some more examples. This question is also given as blueprint question on page 40 in your science textbook in chapter 3. Calculate the formula unit masses of zinc oxide ZnO, sodium oxide Na2O, potassium carbonate K2CO3. Here the atomic masses of the elements present in these compounds are given. By using the values of these atomic masses, you can calculate the formula unit masses of these given compounds. Calculate the formula unit mass of zinc oxide. Again, see how many zinc atoms and oxygen atoms are present in this compound. You can see in this compound zinc oxide, there is one zinc atom and one oxygen atom is present. So multiply one zinc atom with its atomic mass and one oxygen atom with its atomic mass. Then add up their atomic masses. You will get the formula unit mass of zinc oxide. So atomic mass of zinc atom is 65 U, as it is given in this question also, plus atomic mass of oxygen, that is 16 U. So by adding 65 with 16, you will get the formula unit mass of zinc oxide as 81 U or 81 unified mass. Now calculate formula unit mass of sodium oxide. Students, tell me how many sodium atoms are present in this compound? Yes, there are 2 sodium atoms. So multiply 2 with the atomic mass of sodium. Similarly, how many oxygen atoms are present? Yes, there is one oxygen atom. So multiply it with its atomic mass. What is atomic mass of sodium? 23. Multiply it with 2 plus. What is atomic mass of oxygen? 16 U. So multiply 16 U with 1 because there is one oxygen atom. Now add up the atomic masses of sodium and oxygen atoms. So by adding the atomic masses of sodium atoms and oxygen atoms present in this compound, you will get the formula unit mass. So formula unit mass of Na2O comes out to be 62 U. Similarly, you can find the formula unit mass of potassium carbonate by calculating and adding their atomic masses. So how many potassium atoms are present in this compound? You can see from this formula there are 2 atoms of potassium. Multiply it with its atomic mass, that is 39 U. How many carbon atoms are present? You can see there is one carbon atom, so multiply it with its atomic mass, that is 12 U. How many oxygen atoms are present in this compound? You can see there are 3 atoms of oxygen. So multiply it with its atomic mass, that is 16 U. And on calculating the atomic masses of all these atoms and then by adding the atomic masses of all atoms present in this compound, you will get the formula unit mass of potassium carbonate as 138 U. So students, this is all for today's lecture. You can practice many more examples given in your assignments by solving them in your fair notebook. Thank you and have a nice day.